morning all of you. This is your Prabhakar. Welcome to our channel Dawn of Chemistry. We have been discussing about the chemical kinetics. In our previous videos we have discussed about the rate of reaction and then rate expression. In this video let us discuss about the Arrhenius equation, which is very important topic and which is highly susceptible area for asking the questions, and highly interdisciplinary problems also they can ask you based on this Arrhenius equation. This Arrhenius equation explains the effect of temperature on the rate of reaction, and what is collision theory of reaction rates, and what are the energy profile diagrams. That's what we are going to discuss about. Listen carefully. Definitely you will become strong on these topics whatever I explained. If you are new to this channel, subscribe to the channel and click the bell icon for the more updates. Don't forget to like the video and comment on the video. Whatever you want, any further topic or you want any explanation, means you can comment on the comment section, and don't forget to share the video with your friends. Let us get into the details. Arrhenius equation. To understand Arrhenius equation, first we should know collision theory. To understand Arrhenius equation, first we should know collision theory. What is this collision theory and what are the postulates of collision theory? Means, see, whenever you take any gas molecule, always gas molecules will be randomly moving from one place to the another place. During their movement they collide with one another. The gas molecules present in the container always will be colliding with one another, and the number of collisions taking place in the container in 1 second is called as the collision frequency. Collision frequency. Number of collisions taking place in 1 second is called as the collision frequency. The collisions between the molecules are responsible for products formation. All collisions will not form the products. Only collisions with some minimum amount of energy only can form the products. All collisions between the molecules does not lead to the products formation. Only a few collisions with some minimum amount of energy can lead to the products formation, and those collisions are known as the effective collisions. Effective collisions. Always remember, only a few collisions which are having some minimum amount of energy can lead to the formation of the products, and they are known as the effective collisions. Effective collision alone will not form the products. Effective collision is one of the factor. Along with that, there is a factor known as the orientation factor. Orientation factor. Whenever the molecules are colliding with one another, whenever they collide in a particular direction, only they can form the products, and that is known as the orientation factor. When molecules are coming like this and they collide like this, means there is a great chance of forming the products. When molecules are coming like this and they edgewise they collide, means there is no chance for the product formation. Like that, orientation factor also very important to form the products. See, this is very helpful for us to identify the molecularity of the reaction. When two molecules are coming, they go for end-to-end collision. When three molecules are coming, they can go for the effective collision. But when four molecules are coming, it's not possible for them to have an effective collision. So that's why the molecularity of any reaction is limited up to 3 only. Why molecularity of any reaction is limited up to 3 means, because orientation factor more than 3 is not effective. That's why the maximum molecularity for a reaction will be 3. What is molecularity and order means, in the next video I will explain. So according to collision theory, the molecules will be randomly, that is kinetic gas equation also, but this is some advanced thing to that one. We will depend on kinetic theory of gases to derive this Arrhenius equation. So according to collision theory, always there will be regular collisions between the molecules. Only collisions with some minimum amount of energy only can lead to the product formation, and they are known as the effective collisions. And these effective collisions with proper orientation factor leads to the products formation. And the number of collisions taking place in the reaction vessel in 1 second is known as the collision frequency. So like this, collision theory explains why reactant molecules are converted into the products. So see, to form products, some minimum amount of energy is required and proper orientation factor is required. See, if once you raise the temperature, of any gas, that is Arrhenius is nothing but effect of temperature on rate of reaction. Effect of temperature on rate of reaction. So that's why Arrhenius equation will come. Once you raise the temperature of any particular gas, means the gas molecule will absorb the energy and they start randomly moving from one place to the another place. When they start randomly moving from one place to the another place, their velocity increases and their collision frequency increases. So the number of molecules crossing the energy barrier increases. So that's why the rate of reaction also increases. So the rate of reaction dependency on temperature is given by Arrhenius equation. What is Arrhenius equation? Means K is equals to A into exponential minus A by RT, where K is equals to rate constant, A is equals to activation energy, T is equals to temperature, and R is equals to gas constant. So here A is equals to Arrhenius factor, and this is a constant. So Arrhenius constant will come. This Arrhenius constant is a sum of orientation factor also you can consider. Here you see exponential minus A by RT is fraction of molecules crossing energy barrier. Fraction of molecules crossing energy barrier. To understand what is this energy barrier and all, means we should know what is energy profile diagram. That is also explained by using this collision theory only. What is this energy profile diagram? As the temperature increases, collisions, effective collisions increase, so rate also increases. See, what is energy profile diagram? So according to collision theory, collisions will be happening, that is collision frequency. Only particular collisions with some minimum amount of energy only can form the products. They are known as the effective collisions. When effective collisions with proper orientation only can lead to the products formation. Once you raise the temperature, means the number of collisions increases and hence the rate of reaction increases, and Arrhenius equation is based on this effect. So here you see exponential minus A by RT means activation energy. What is this activation energy means? We will understand in the energy profile diagram. This is very important one, man. Listen carefully. What is this energy profile diagram? A plot between I will explain for one so you can easily understand this. On x-axis, I will take extent of reaction, and on the y-axis, I will take energy. A plot between energy versus extent of reaction is called as the energy profile diagram. So in the starting, we will be having reactants. As the time is going on, the energy of this will be gradually increasing and it will reach to a maximum state. So whenever a reaction is happening, the reactant molecules will be colliding with one another. So that's why initially the reactants will have lower amount of energy. As the time is going on, the reactant molecules will be colliding with one another. So they will be reacting with one another and they will form a high energy complex known as activated complex. So the reactant molecules will be reacting with one another and they rise in their energies and they will form a activated complex. This is also known as transition state. The transition state is the higher energy state. After transition state formation, the transition state will break up into the products. Here this will be the products will come. So whenever any reactants are being converted into the products means definitely they have to form an activated complex. So what is this activated complex means? The reactant molecules collide with one another and they will form a highly unstable complex and that is known as the activated complex. The energy possessed by activated complex is known as threshold energy. The energy possessed by the activated complex or transition state is called as the threshold energy. If you see, this is the energy of reactants, this is the threshold energy. What happens to this? This is energy of reactants and this is threshold energy, and here you see from here to here is known as the activation energy. The energy required by the reactant molecules to reach the transition state is called as the activation energy. So you can see very clearly the energy from this spot to this spot is threshold energy. The energy from this spot to this spot is energy of reactants and the remaining energy is activation energy. Here this is energy of products. Here you see the difference between energy of reactants and energy of products is known as the enthalpy of reaction. Since the product's energy is more than the reactant's energy, it is absorbing some amount of energy. So this is a endothermic reaction. Like this, collision theory explains the happening of a reaction. According to collision theory, the collisions will happen. Because of the collisions, activated complex or transition state will come. The transition state will break down into products. During this process, energy required by the reactant molecules to reach the transition state is known as the activation energy, and the total energy possessed by the activated complex is known as the threshold energy. The energy difference between the reactants and products is known as the enthalpy of reaction. Since products energy is more than that of reactants energy, this is known as a endothermic reaction. So according to collision theory, this is the energy profile diagram for the endothermic reaction. Here you see exponential minus EA by RT are the fraction of molecules crossing energy barrier. Here this is the energy barrier. So whatever the molecules are crossing this energy barrier, they only can form the product. So that is the fraction of molecules crossing this energy barrier is called as the exponential minus EA by R. This is for endothermic reaction. Let us write for exothermic reaction. Here only I will write for exothermic. I will rub this thing. Here you can write energy on this axis and extent of reaction I will write here. I will write energy of reactants and it will form here energy of products. Here energy of reactants, this is activation energy, and from this to this is threshold energy. So how can you write threshold energy? Means here this is enthalpy of a reaction. Here threshold energy is equals to activation energy plus energy of reactants. We come like this. We can study about the energy profile diagram. So what is an energy profile diagram? This is for exothermic reaction. So see the enthalpy of reaction equals to energy of products minus energy of reactants. Threshold energy equals to activation energy plus energy of reactants will come. One more important thing. If forward reaction is exothermic, backward reaction will be endothermic. Forward reaction is endothermic, backward reaction will be exothermic. This is a very, very important point you have to understand. Reaction forward is exo, reaction backward will be endo, will be coming. This is very, very important one. So let us see how they can ask you problems based on this energy profile diagrams. From the energy profile diagram, they will give you energy of reactants and they will give you energy of products, and they will ask you write the enthalpy of reaction, or they will ask you forward reaction activation energy they will give you. They will ask you what is the backward reaction activation energy. That kind of problems they will ask you. Let me tell you how they can ask a problem. Means hope you have taken down this thing. If not, means you can go through. Let me tell you one problem how they can ask based on this. See, why I am clubbing these two here means if you study in that manner means you can easily understand the concept. If you study different or alag means it will be difficult for you. So see this energy profile diagram. Energy of reactants 0, 10, 20, 30, 40, 50, 60, 70, 80. Energy kilojoule per mole. Extent of reaction. So see, this is the energy profile diagram. The question is find energy of reactants, energy of products, activation energy of forward reaction, activation energy of backward reaction, enthalpy of reaction, threshold energy. This is the question they are asking you. So this is the question. This is the energy profile diagram. Find energy of reactants, energy of products, activation energy of forward reaction, activation energy of backward reaction, enthalpy of reaction and threshold energy. Let us see. I told you very clearly whatever is related to this products and this one is reactants. So energy of reactants exactly equals to 20. Energy of reactants is 20 in kilojoules per mole. Energy of products is 10. What is activation energy of forward reaction? From here to here, whatever is the difference is there. What is the difference? This point is 20, this point is 80. So the difference will be 60 will come. So the activation energy of forward reaction is 60. Wonderful. What will be the activation energy of backward reaction? Energy difference from this point to this point, right? Whatever is the energy difference from this point to this point, means this is 10 and this is 80. The difference is 70. So that's why activation energy of backward reaction is 70. How you will get activation energy of backward reaction is 70? EAB is equals to activation energy of backward reaction equals to activation energy of forward reaction plus energy of products will come. So that's why this is a 10 and this is 60. So that's why it will be activation energy of forward reaction plus energy of products will come. If it is a backward reaction, endothermic means it will be backward will be, this is for exo, and for endo activation energy of backward reaction equals to activation energy of forward reaction minus, let me tell you this is energy of reactants, energy of products. This is activation energy of forward reaction. You want activation energy of backward reaction. So how you can get this thing means this only you need. What you will do, this is energy of reactant. So that's why activation energy of backward, only this portion you want. You have this portion, this portion is nothing but what? Energy of products. This total portion, threshold energy minus energy of products is nothing but activation energy of backward reaction. What is threshold energy? Energy of reactants plus activation energy of forward reaction minus energy of products will come. So that's why it will be activation energy of forward reaction plus energy of reactants. This is energy of reactants minus energy of products. This is a very, very important thing. Let us see. Be careful with this model, activation energy. Once they give you forward, here I have given you the values in the graph, there is no problem for you. But in the reaction, they will give you activation energy of forward reaction, energy of products, and they will ask you activation energy of backward reaction. So like this case means you can do very easily for exo case. For endothermic reaction, it is not like that. So the reverse will be coming. So whatever is this kind is there. So this much energy you want means they give you only this much only. Minus EP means the value is very big. So that's why you have to bring this energy of reactants also to this thing, and you have to get this one. Activation energy of forward reaction plus activation energy of reactants minus energy of products will come. You will get the answer. What is enthalpy of reaction means? Energy of products minus energy of reactant. So this is only will be coming. So that's why what will come? Enthalpy of a reaction. What will be coming? 20 and 10 means it will be 10 kilojoules will come. And you can write this thing ER, EP minus ER. You can write in this form also. There is no problem at all. Next, threshold energy. What is threshold energy means? Total energy, sir. Energy of transition state is nothing but the threshold energy. Like this, we can understand the problems based on the energy profile diagrams. Hope you understood this thing. So, what is cohesion theory of reaction rates? What are the postulates of cohesion theory of reaction rates? And what is energy profile diagram, and how they can ask problem based on this energy profile diagram? See, I didn't still go into the Arrhenius equation. Different forms are there for Arrhenius equation. I will explain them also, no problem. Right. Sir, what is the advanced level of asking problem in this energy profile diagrams? Let us move on. Hope you have taken this thing. You can take some time and you can take that. I am rubbing this one. Let us see. Finding number of transition states and intermediates. Finding number of transition states and intermediates. See, in any energy profile diagram, number of intermediates is equals to number of depressions or crests, and number of transition states is equals to number of peaks. This is very important. If you see, for example, SN1 reaction, we know very well in SN1 reaction that takes place in two steps. In the first step, intermediate will come, carbocation or carbocation. After that, the another step will be attack of the nucleophile will be there. So this is an intermediate 1, this is intermediate 2 will come. No, sorry. This is transition state 1 and this is transition state 2 and this is intermediate 1. And here this is an endothermic reaction. If you see this thing, in a given energy profile diagram or in a given diagram or according to the diagram, the reaction happens in how many steps? The first question. How many transition states are there? That is second question. And how many intermediates are there? That is third question. So transition states is equals to, this is TS1, TS2 and TS3. So number of peaks is nothing but the transition states. This is intermediate 1 and this is intermediate 2. So that's why transition states are 3, intermediates are 2. And how many steps means? This is one step. So step 1, this is step 2 and this is a step 3. So total steps are 3. So number of steps is equals to number of transition states will come. And this is an exothermic or endothermic means exothermic reaction, because energy of products is lower than the energy of reactant. So this is an exothermic reaction. Like this, number of questions they can ask you based on this transition states and finding the energy changes in the reaction. So be careful with these things also. So far what we have discussed means what is collision theory, what is the main reason for the product's formation, and what are the basic definitions are present to understand the collision theory, what is activation energy, what is threshold energy, and what is energy of activation energy of forward reaction, what is activation energy of backward reaction, what is energy of products and what is energy of reactants, and how to do problems based on the energy profile diagrams, and how to understand the energy profile diagram, and how to identify number of intermediates and number of transition states in the energy profile diagrams. That is the thing regarding energy profile diagram, and complete type of questions they can be asked based on the energy profile diagrams and collision theory. After that, we will come into the Arrhenius equation. In this Arrhenius equation, activation energy, fraction of molecules crossing energy barrier is this thing. Now let us discuss about how many types of Arrhenius equations are there and what are the different modifications of Arrhenius equation. Have a look on these things. Right. I'm rubbing this thing and let us move on. see, we know that K is equals to A into exponential minus A by RT. If you remove the exponential, ln K is equals to ln A minus A by RT. Another form, 2.303 log K. ln A is equals to 2.303 log A. So this is the formula. 2.303 log A minus A by RT. Divide by 2.303. Log K is equals to log A minus A by 2.303 RT will come. This is in a form of y is equals to C minus mx. If you plot a graph between log K values on y-axis and 1 by t values on the x-axis, you will get a straight line with a slope value equals to A by 2.303r and the intercept value will be log A will come. So listen carefully. They will give plot like this and they will ask you find activation energy. That is one type of asking question. Or if you plot a graph between ln K value, here you see ln K value versus 1 by t value, you will get a same slope, but this will be A by R will come and this will be ln A will be coming. Like this, two different ways you can draw the plot for the Arrhenius equation. This is a direct one. So which of the following plot is correct for the Arrhenius equation? Or they will give you the values of this thing, or they will give you the angle of this, theta they will give you. You know very well, theta is nothing but the slope. Tan theta equals to A by 2.303 R will come. Directly you can calculate the activation energy. If you know this logic means you can do the problems. If you don't know this logic means you can't do anything. So be careful with this thing. So this is how they can ask you direct question based on this temperature values. If at different temperatures, how to find the rate constant means, let us see. I am clearing this thing. Let us take two different temperatures are there. When temperature is T1, the rate constant let us take K1. So it will be log K1 is equals to log A minus A by 2.303 or 1 by T1. When the temperature is raised to T2, the rate constant changes to K2. So that's why log K2 is equals to log A minus A by 2.303 or 1 by T2. Take this equation 1 and take this equation 2. Go for 2 minus 1. Log K2 by K1 is equals to, this is 1 minus 2, so this is minus log K2 minus log K1 means log K2 by K1. Log A gets cancelled, so that's why this is minus, this means this will be plus. A by 2.303 R 1 by T1 minus 1 by T2. This is the another form of Arrhenius equation at two different temperatures. Like this, interchanging of the equations or converting one equation into another form, that kind of questions also they will be asking you based on this Arrhenius equation. Like this, we can study about the what is Arrhenius equation, what are the different forms of Arrhenius equation. Here at two different temperatures, one they will give you, other they will ask you, or K2 by K1 ratio they will give you, they will ask you to find one of the temperature value, or in the graph they will give you the plot and they will give the angle and they will ask you to find the activation energy. Like this, a number of questions they can ask you based on this Arrhenius equation. All this Arrhenius equation and collision theory are based on the Maxwell distribution curves are there. Based on those curves we can do all these things. That is the thing regarding what is collision theory of reaction rates, what is energy profile diagrams, what are the different applications of energy profile diagrams, what is Arrhenius equation, what are the different forms of Arrhenius equation. That is for this video of Arrhenius equation and how to do the problems based on Arrhenius equation. Now let us see another important thing, temperature coefficient. Mu. So what is this temperature quotient mu means? It is known that for every 10 degrees centigrade rise of temperature, the rate of reaction nearly doubles. If you see, for every 10 degrees centigrade rise of temperature, rate of reaction doubles. So this is the basic thing they have understood by doing so many reactions and by studying so many reactions. If you observe this thing, they have proposed temperature quotient mu Kt plus 10 by Kt. So you can define this as a ratio of rate constants of two reactions which are present at two different temperatures that differ by 10 degrees centigrade is called as the temperature quotient. Listen carefully. The ratio of rate constants at two different temperatures that differ one another by 10 degrees centigrade is called as the temperature quotient. Generally, the temperature quotient value will be in between 2 and 3 will come. Based on this temperature quotient, number of problems they will be asking you. Listen carefully. They will give you rate constant K2 at temperature T2, rate constant K1 at temperature T1, and they will give you the mu value. Or they will ask you to find what is mu value. We know very well K2 by K1 is equals to mu power T2 minus T1 by 10. So K2 by K1 is equals to mu power delta T by 10. If you take logarithms, log K2 by K1 is equals to delta T by 10, log mu will be coming. By using this formula, we can find out the mu value. Like this, we can easily identify the mu value, or you can find the K2 by K1 relations. Or directly by using this equation, we can identify the temperature quotient. Based on this also, they will ask you number of problems. Be careful. Let me tell you one more thing. They will give you plots. These are related to the Arrhenius equation. I am telling here log k values versus 1 by t values, ln k value versus 1 by t values. This is A1, A2. So they give you this thing. In which case, what is the relation between EA1 and EA2 they will be asking you. So at two different reactions, this is reaction 1 and this is reaction 2, and they have carried out at different temperatures and they have plotted the graph. What is the relation between EA1 and EA2? Which is having more slope means this is with less slope, this is with more slope. You can see these two things. Here theta is maximum, here theta is minimum will be coming. So like this, when theta value increases or the slope value increases, when the slope value increases, the activation energy also increases. If the slope value decreases, activation energy decreases. So A1 is less than A2. So be careful with this kind of things also. And based on relation between rate of reaction versus temperature, there are different types of reactions are there. What are the different types of reactions based on the relation between temperature versus rate of reaction? If you plot a graph between temperature versus rate of reaction, they will give the plot and they will ask you it comes under which kind of reaction, temperature versus rate. If you take rate of reaction on y-axis and temperature on the x-axis and plot the graph, so see, for general reactions, you know very well, as the temperature increases, the rate of reaction increases. These reactions are known as the normal reactions. For normal reactions, as the temperature increases, the rate of reaction also gradually increases. Some reactions are there, as you rise the temperature, rate of reaction increases. After some time, the reaction's rate will become infinity. This kind of reactions are known as the explosion reactions. This kind of reactions are known as the explosion reactions. As the temperature increases, the rate of reaction gradually increases. That is known as the explosion reactions. Some reactions will be there. As the temperature increases, the rate of reaction gradually increases. After that, it decreases. These are known as the enzyme reactions. These are known as the enzyme reactions. Some reactions are there. As the temperature increases, the rate of reaction gradually increases and then it will be decreased. Another kind of reactions are there. Oxidation of carbon reactions are there. This is oxidation of carbon. As the temperature increases, the rate of reaction increases, and then as the temperature increases, it decreases. These are known as the oxidation of carbon. There is one more reaction that is very important reaction. The only reaction which shows the decrease of rate of reaction with increase of temperature is this reaction. 2NO plus O2 gives 2NO2 will come. This is the only reaction for which the rate of reaction decreases with increase of temperature. Like this, we can study different kind of reactions, then the rate of reaction with the temperature. They will give the plot and they will ask you classify that into which kind of reaction, or it comes under which kind of reactions. Always remember, irrespective of exothermic or endothermic reaction, the rate of reaction increases with the rise of temperature since it has to cross the energy barrier. For enzymatic reactions, increases, decreases, normal it increases, explosion, sudden jump will be there, oxidation of carbon increases and then decreases, and for NO reactions it gradually decreases. Like this, we can completely study about the effect of temperature on the rate of reaction, what is Arrhenius equation, and what is temperature quotient, what is energy profile diagram, and what is collision theory of reaction.